So what if I told you that going to Mars might not just be a one-way trip emotionally, but physically, biologically, and maybe even permanently? We've all seen the headlines. NASA plans human mission to Mars. SpaceX targets red planet by the 2030s. Terraforming Mars, sci-fi or future. But there's something these headlines skip over. Something most people don't realize. It's not just hard to get to Mars. It's even harder to come back. And not just because it's far away. Not just because of the rocket science. But because once you leave Earth for that kind of journey, you're leaving behind more than just a planet. You're leaving behind the conditions your body evolved for, the systems that keep you alive automatically, and even the kind of time that life on Earth runs on. In this video, we're diving into exactly why going to Mars might mean never setting foot on Earth again, even if you survive the whole thing. Let's break it down. The first thing you need to understand, Mars doesn't play by our schedule. It's not like flying to a foreign country and then booking a return flight for the following week. Earth and Mars orbit the Sun at different speeds and distances. That means you can't just go to Mars and come back whenever you feel like it. You have to wait for the orbits to line up again, and that only happens roughly once every 26 months. This is called a launch window, and it's non-negotiable. Space agencies plan missions years in advance to take advantage of these rare alignment windows. Miss one, and you're stuck for another 2 years minimum. Let's say you launch during a good window and make it to Mars in about 6-9 months. That's just the first third of your trip. Once you land, you'll likely need to stay for over 500 days before Earth and Mars are properly aligned again for the return. So the full trip, including travel time, waiting, and the ride back, ends up being around 900 days. That's 2.5 years, best case. And here's the kicker. There is no backup Uber. There's no rapid rescue option. If something goes wrong with your health, your ship, your supplies, Earth can't help you in time. Even if they could launch a rocket on short notice, the orbital alignment probably won't let it reach you until it's too late. And that's assuming the Mars mission even includes a return plan. Some concepts, including early versions of SpaceX's colonization blueprint, prioritize building a permanent presence over sending people back. So, if you sign up, you may be signing away any guarantee of return. Not out of malice, out of math. Once you leave Earth's magnetic field, you're naked in a cosmic shooting gallery. That's not an exaggeration. Earth's magnetosphere and thick atmosphere protect us from the constant rain of cosmic radiation. But in deep space, and especially on Mars, which has no global magnetic field and only a thin atmosphere, you're directly exposed to galactic cosmic rays, which are basically high-energy particles from outside our solar system, and solar particle events, which are sudden, intense blasts of radiation from the sun. These aren't just small background threats. They damage cells, DNA, and brain tissue. NASA's Human Research Program has repeatedly warned that long-term exposure to space radiation is not a minor or abstract risk, but a serious health concern that follows astronauts long after the mission ends. Extended time beyond Earth's protective magnetic field can significantly increase the likelihood of developing cancer later in life, as high-energy particles damage DNA in ways the body cannot always repair. The cardiovascular system is also at risk, with studies suggesting a higher chance of heart disease due to radiation-induced inflammation and vascular damage. Even the eyes are vulnerable, as prolonged exposure has been linked to the development of cataracts, which can impair vision years after exposure. More concerning still is the potential impact on the nervous system. Radiation may contribute to gradual neural degeneration, affecting coordination, reaction time, and overall neurological health. Some research also points to subtle but lasting changes in cognitive function and emotional regulation, including memory issues and mood disturbances. What makes this especially difficult is that there is no complete solution. Current spacecraft and habitat designs can reduce radiation exposure, but they cannot block it entirely. No matter how advanced the shielding becomes, a portion of this radiation will always reach the human body, making it an unavoidable part of long-duration space travel. No realistic spacecraft or Mars habitat can block it all. Even water shielding or polyethylene materials only reduce exposure. They don't eliminate it. Over time, your risk just stacks up. Astronauts who've spent time on the ISS, which is still protected somewhat by Earth's magnetic field, already show signs of increased health risks. A Mars trip would expose you to 5 to 10 times more radiation. So even if you do return to Earth, you might return with a higher risk of cancer, or with brain function that's not quite the same. In some scenarios, your body might be carrying the kind of damage that changes your life permanently. And because the effects aren't immediate, you might not even know what changed until years later. On paper, Mars is a destination, but in reality, it might be the thing that redefines your biology forever. It's easy to think about the Mars mission like a round-trip airline ticket, but here's what nobody tells you. You don't have a return rocket unless you build one on Mars. Let that sink in. Every rocket that carried humans to the moon launched from Earth with its fuel tanks already full, supported by an entire ecosystem of infrastructure, engineers, and real-time assistance. There were people monitoring every step, machines in place to handle emergencies, and decades of atmospheric testing to rely on. But when it comes to Mars, none of that support exists. There's no launch pad, no technicians, no fallback. If astronauts want to return from Mars, they'll have to launch a brand new rocket from the surface of Mars itself. That's already a massive challenge, but it doesn't stop there. The rocket will have to overcome Mars's gravity while operating in an atmosphere that's less than 1% the thickness of Earth's, making liftoff and engine performance a completely different game. It also has to carry enough fuel and oxygen to break orbit, survive the vacuum of space, and make the months-long journey back to Earth. And finally, it has to dock with an orbiting vehicle or begin re-entry solo, all without the kind of support we've always relied on. It might sound doable in theory, but in practice, it's a whole different level of complexity. Mars doesn't hand out second chances. NASA's upcoming Mars sample return mission is trying to launch a small canister of rocks off the planet using a lightweight vehicle called the Mars Ascent Vehicle. And even that's taken over a decade of planning, design, and funding just to launch a few kilos of material. Now imagine doing it with human lives at stake, from an environment with extreme dust storms, temperature swings, and no support crew. That's why so many plans focus on ISRU, in situ resource utilization, meaning make your fuel and oxygen on Mars. NASA's MOXIE experiment successfully made oxygen from Mars's atmosphere. It was a big win, but it made only a few grams per hour and was the size of a toaster. To fuel a rocket home, you'd need thousands of kilograms. That's like saying, we proved you can start a campfire. Now build a space heater that can keep a city alive. Let's talk about something people rarely mention, what it means psychologically to know you may never return. Even just planning for that kind of journey changes your brain. The moment you commit to a multi-year mission with no emergency exit, your mind has to rewire for survival. There's no home in reach. You can't call your family and expect an instant response. Light-speed delay means even talking to Earth can take up to 24 minutes one way. You're cut off in a way no astronaut in history has ever experienced. Researchers have studied how isolation affects human psychology by observing people in extreme environments like Antarctica research stations, deep-sea submarines, and Mars simulation habitats. Across all of these settings, one trend is clear. When people are cut off from the outside world for long periods, their mental state begins to shift. Sleep patterns become irregular or disrupted. Emotional regulation breaks down, leading to frequent mood swings. Tensions rise, sometimes escalating into social conflict within small teams. Over time, motivation starts to decline, and in some cases, symptoms of depression emerge. These are environments that, while difficult, still allow for breathable air, medical evacuation, and occasional contact with the outside world. Now imagine that same psychological pressure, but on Mars, a place where going outside without a suit means instant death. A planet where the soil is laced with toxic chemicals, the air is unbreathable, and the sky is a cold, lifeless red. There's no sunbathing, no breeze, no fresh food, no real-time calls home. Every day is survival, with no option to opt out. The weight of that reality doesn't just wear on your body. It can fundamentally change how your mind operates under stress, isolation, and the haunting permanence of being millions of miles from Earth. Even if you survive, your sense of self might not. Some astronauts have said space changed them permanently, not in a poetic, cinematic way, but in the sense of how they related to the world, to time, to people, to noise, to light. Now imagine that after 3 years on Mars, you return to Earth and nothing feels familiar anymore. Food tastes wrong, conversations feel shallow, the sky is too blue, gravity hurts your joints. What if your body returns, but your mind doesn't? And that's for those who do come back. So, why does going to Mars mean you might never return? It's not because we can't. It's because the universe doesn't make it easy, and Mars doesn't care about your plans. You have to wait for the planets to line up. You have to survive radiation that Earth never prepared you for. You have to launch off another world with systems no one's tested at scale. You have to manage your own sanity when Earth becomes a distant dot in the sky. And even if every piece of tech works, even if you land safely, survive the stay and launch home, you might not come back the same. And maybe, just maybe, you're not supposed to. Because some journeys aren't about returning. They're about becoming something or someone. You can't become unless you leave everything behind. That's the real reason Mars may be a one-way trip. Not because we can't return, but because in every sense of the word, we don't.